Hi there, and welcome to Ian's Engage channel. I'm Ian. In a previous video, I showed how I'd modified the test track to include a curved Setrack point in anticipation of testing it. In this video, I'm going to show how I began the testing to determine whether or not I would include one in the Shelfington layout design. So, the plan was simple. First, I was going to run all of my locos through both lanes of the curved point, in both directions and at various speeds, and note any problems. I'd then move on to pulling and pushing rakes of rolling stock across the point to determine what types of coaches and wagons were likely to encounter problems. I'd then make a decision based on the results whether or not to include a curved Setrack point on Shelfington. So, let the experimentation begin. First up was the ever-reliable Dapple Class 33 Templecoombe. I ran the 33 at moderate speed. I then ran the 33 at an average speed. Next, I ran the loco quite quickly. I then ran the loco at some progressively slower speeds. With this first loco, I'll show the wide variety of runs that I performed with all of the locos. However, with subsequent locos, I won't show all of the runs and will concentrate on a smaller selection, mostly concentrating on runs where problems occurred. As expected, the 33 was most obliging, and there was no issue with whichever direction or lane I chose to run through. Next up was a Graham Farish Class 31. Again, I ran the loco at a range of speeds. I was very pleased with how the loco performed at low speed, with the crawl almost matching that of the Class 33. The performance of the 31 was pretty much flawless, although for some reason I couldn't seem to run the loco at its very top speed, which I assumed was something to do with a communication problem between the NCE power cab and the decoder fitted to the loco, but that was an investigation for another day. Something with a smaller wheelbase was tried next, as a Farish Class 03 took centre stage. I was a bit disappointed to see this loco judder and pause slightly across the point work on various occasions. And it was defeated a couple of times when running at slow speeds, requiring a helping hand to get it moving again. I've highlighted the bad running here, but on the whole, it succeeded across the point many more times than it failed. Next came the Farish Class 08. During one of the traversals of the point, the loco simply stopped dead in its tracks.
What the hell?
Well, I say stopped, but the wheels were still turning. The problem couldn't be electrical, so there must have been some sort of physical barrier.
Okay, so that's definitely very odd.
I gave the little 08 some encouragement, but it wouldn't cross the point. I checked the track by running my finger across it. There didn't seem to be any physical obstructions. I ran the loco around the track while I gave the problem some thought. However, what I wasn't expecting was it to stall on one of the points at the front of the test track. Now that definitely wasn't right. I needed to take a closer look. It didn't take long to find the problem. I was dismayed to find that there were now 2 pickups hanging loose, and that these were seemingly jamming in the frog of the point as the loco tried to cross over it. Now, obviously, this wasn't a problem with the point, but rather with the annoyingly temperamental Farish 08. I just about managed to refrain from chucking the loco in the bin, instead placing it to one side for the time being. I'd try fixing it again later. Carrying on with the experiment, a Farish Class 20 was up next. Having not been run for a while, the motor was a bit jittery, and the loco needed a couple of pushes to get it going again. But this was on the track sections and not on the point itself. And yes, I know it sounds like it's derailed, but it isn't, honest. The loco actually had no problem at all taking any of the lanes of the point at any speed. Next into the spotlight was the N-Gauge Society's little Hunslet. The Hunslet came to a standstill on its first attempt to cross the point, and needed help. Although this was the smallest loco on test, I wasn't expecting it to fail, as it was fitted with a stay alive, which should easily cope with the large dead frogs of the Inselfrog point I was testing. However, I was wrong. This was quite perplexing, as it was so out of the blue. Time and time again, I tried to crawl over the point, but about 75% of the time I was met with failure. Obviously, I'm showing mostly the failures here. I found that the only way to cross the point reliably was to increase the speed to step 50, as anything below that produced unpredictable results. This seemed to be a similar issue to the one the Class 03 had encountered, but it happened much more frequently. In the long term, I wasn't sure if I could live with having to speed locos up to cross points, so some further investigation would be required. Next up was the Graham Farish Class 37, which was my biggest loco in the test. Having pickups on all wheels, I was expecting this loco to sail through the tests. However, the loco sometimes exhibited an annoying stutter as it navigated the outer lane when travelling at speed step 50. But what was worse was that it sometimes stalled when crawling through either lane at speed step 20 or below. Again, I'm showing the worst cases here, but stalling happened roughly half of the time the loco passed through the point at low speed. I thought it was interesting how my biggest and smallest locos behaved similarly to each other. However, after thinking about it for a while, the Hunslet and O3 wheel sets were of a similar dimension to the bogies of the Class 37, so maybe they were jamming in the same way. Maybe I should have foreseen the problem. More thought was definitely required though, as with a similar sized Class 56 on order, and Classes 40, 45, 47, 50 and 55 on my wish list, I could see them all exhibiting similar behaviour, which would be infuriating at best. So it wasn't looking good for keeping a curved Setrack point in my track plan. Next on test was a Farish Class 101. I decided to test this with only the drive car. It sailed through both lanes of the point work with no problems at all. The Dapple Class 122 was next to undergo testing. Again, the loco navigated the point work quickly and slowly in both directions without any issues. The next loco quickly coming into frame is the Dapple Class 43. While all of the other locos I've tested here have been DCC fitted, this one is using DC. So apologies for the abrupt starts and stops and the ham-fisted control of the loco. Like the Class 101, I'm also only testing the drive car at this point. And also like the Class 101, it passes through both lanes in both directions at both high and low speed. Finally, going under test we have the Graham Farish Standard Class 5 MT. As the only steamer in the test, I was hoping that the 460 wheel configuration would give a good representation of how most 6 main wheel steamers would navigate the curved Setrack point. There was a bit of a wobble on a minority of the passes, and on the whole the loco performed very well, and didn't stall at any point during the test. So, those were all of my different loco types, and most had performed very well across the point for the majority of the time. However, all of the locos had exhibited some sort of wobble, stutter or judder as they passed through one or both of the lanes, although I wasn't sure whether I should be too worried about that or not. I was a little concerned that all of my small shunters had experienced a problem during its test, and more than a little concerned that the Class 37 had also exhibited a couple of problems. I would never have expected it to stall, for instance. I'd been expecting any problem I encountered to be electrical, because of the large plastic area occupied by the frog. However, I'd used a new point with new rail joiners, and it was obvious that there was current at each end of the point from watching how the locos behaved. I'm certain that all of the issues were caused by wheel sets jamming as they traversed the frog, and was beginning to wonder if I could maybe file a portion of the frog away to provide better running. Okay, so that's about it for this update. In part 2, I'll be testing different types of rolling stock, and will finally come to a decision on whether I'll use the curved Setrack point on Shelfington or not. Of course, if you have any thoughts on the subject, then please let me know. But please don't suggest using a streamlined curved point, as I can't fit one in at the location required. Alternatively, if you've got any hints, tips, useful tools or techniques to pass on to a beginner in N-gauge modelling, or if you simply want to say hello, then please do so in the comments section. Anything and everything you've got to say will be greatly appreciated. In the meantime, thanks very much for watching. Hopefully I'll have another update on my progress soon. Bye.